Hello and welcome to today's daily Leetcode challenge. We'll be solving the solution and then stick around for the end of the video where we compare our solution against others. Okay, question 518, coin change 2. You're given an integer array coins representing coins of different denominations and an integer amount representing the total amount of money. Return the number of combinations that make up that amount. If the amount of money cannot be made up by any combination of all the coins, return 0. You may assume that you have an infinite number of each kind of coins, so only the denomination matters. The number is guaranteed to fit into a signed 32-bit integer, so the amount, I'm guessing. Okay, so this is a classic dynamic programming question where we're asked, and let me put it in my own words, we're given a sum, or we're given an amount, and we have to figure out how many different combinations of either pennies, dimes, or quarters are there to make up that amount. Again, so let's look at a couple of examples. Example 1, you have the amount 5, so you're trying to make, let's say, $5, and you have 3 types of bills. You have a $1 bill, a $2 bill, and a $5 bill. And the output is there are 5 different combinations of those amounts. We're not even combination. Would it be combination? No, because combination. Well, fine, combinations, but not in the mathematical meaning of that word. There are 4 different combinations of these bills that you can create to have the output equal 5, and these are the examples. There's 5 ones, 1, 2, and 3 ones, 2 twos, and 1 1, and 1 5. Okay, and so I guess since I already said that it's a dynamic programming problem, I sort of gave it away, but the idea is the question that you want to ask is for a given coin. Let me start over. It's not the question. It's not just the question that I have to ask that gives away this answer, but also the data structures involved. And one data structure that we're going to implement is an array of integers representing 0 indexed, representing different amount from 0 to the amount that's provided to us in the input. So that array is going to signify the number of combinations given these coins that we can make from 0 to amount. So at the 0th index, the answer there will be what number of combinations that we can make to make the amount 0. And the answer would be there would be only 1, because the only way to make 0 is to just not include anything. The next index of that array is going to represent the amount 1. And the question there is how many different combinations of coins can we create to make the amount 1? And there's going to be an answer for that, and so on until amount. So let's begin our implementation. Well, actually, before that, right. And so why this approach to this solution is effective is because for each consecutive coin, after we look at coin number 1, which is just the $1 bill, you can ask yourself the same question over and over and over again. For a specific amount, how many different ways, how many different combinations can I make that amount given the number of coins that I've already given a specific coin? And the answer to that is going to be the amount equal to current amount minus coin plus the current existing number of ways to make that amount. Let me maybe write this out first. So dp is going to be just an array of amount plus 1. It has to be plus 1 because we're saying that we're saying that amount that this dynamic programming dp array represents different amounts from 0 to amount. So if amount is 5, then we need 0, 1, 2, 3, 4, 5, which is 6. So amount plus 1. Let's set dp of 0 equal to 1, signifying that there's only one combination to make the amount 0. And then how do we use this dp array while we're iterating through different coins while we're looking at different coins to make up that amount? What is the relationship? Well, I claim that for any coin, the number of combinations to make current amount equals, and here I'm going to say equals, dp of current amount plus dp of current amount minus coin. And so how do I say this in English? The current amount, to make the current amount, for example, we're looking at the amount 3, and the coin is 1. For the amount 3, it takes the current ways to make 3, which initially is 0, plus however many ways it takes to make, and this is the current amount, which is however many ways it takes to make the current amount minus the coin. The current amount minus the coin. And so how that looks in code is for coin and coins. So we're exploring each coin at a time. For I in range from coin that we're looking at to amount plus 1, dp of I, which is the current index representing the amount that I'm currently looking at. It's for each coin, it's going to go from the coin itself to the final amount, plus equals plus equals dp of I minus coin. And yeah, and at the end, since our dp goes from 0 to amount, it's good enough to just return dp minus 1. So this is a very classical problem, and I don't think there's much really to discuss even after we submit, but nevertheless, let's look at the solution. And yeah, there are no better solutions, so actually there won't be any comparing. This is the most simple way, but I'm sure that the ones down the line are also using the same strategy. Yeah, this is one of those you must know. So, good thing that we beat pretty much everything. Cool. All right. Well, thanks for watching, and see you next time. Bye.